Okay, so I think we can start, sir.
Yes, please go ahead.
Okay, sir.
Yeah.
Yes, sir.
Are you able to see the presentation?
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Am I audible? Sorry. Hello.
Yes, sir.
Okay, sorry. Actually, I was speaking. I forgot that the is muted. Okay, thank you. So now, sample. Whenever a request is there, and we receive the samples, we may do the sampling, and our laboratory representative will go to the customer site, and they will collect the sample and forward to the laboratory. That is the second. And third one is customer in person. They will visit our laboratory and hand over the samples for the testing. So in these three ways, we can receive the sample in the laboratory. Once the sample is received in the laboratory, and it is a laboratory, the samples are in the custody of laboratory. When the sample are in the custody of the laboratory, right from the sample receipt to testing and handling of testing during the testing time, sample item during testing or calibration, or after that we may hand over the samples to the customer, or we may dispose the samples as per the requirement or as per our contract. So till that time, the samples are in the custody of laboratory, and it is the laboratory is responsible to take care of the integrity of the sample. So entire life of the sample in the laboratory, so the integrity of the sample must be maintained. It is the responsibility of the laboratory. So that for any reasons the sample is to be retested, or customer may ask the sample for retesting as per his interest. Then also we have to ensure that the results are to be uh, matched with our previous results. So for that accordingly we have to maintain the sample so that the integrity of sample is retained. So that is very, very critical. So this is addressed under class number 7.4, handling of test or calibration item. So as per class number 7.4.1, the laboratory shall have a procedure for the transportation, receipt, handling, protection, storage, retention, and disposal or return of test or calibration item, including all provisions necessary to protect the integrity of the test or calibration item and to protect the interest of the laboratory as well as the customer. So as per class number 7.4.1, laboratory must have a procedure. In that procedure, how we are transporting the sample to the laboratory or in the laboratory, and how we are receiving the samples at the laboratory. After receipt, how we can handle the sample for when we receiving the sample and forwarding to the respective testing area. There in the technical personnel, they will take the sample, do some sample preparation and all. So at the time, how they are handling the sample, and in between they have to store the sample uh, during testing or in between testing, even after testing. So how that is being stored, and so that it should be properly protected. So as long the integrity of the sample must be maintained. It should not be lost or deteriorated. So accordingly, you have to maintain. So for that, the procedure must address, and the sample must be retained as per our requirement, our policy, our customer requirements, our regulatory requirements. So maybe samples after testing we may retain for so 1 week or 1 month or 3 months or 6 months, depending on the requirements. Certain samples we may dispose immediately after testing. That is also possible. So what is our retention policy? So mostly our policy must fulfill the requirements of our customer and regulatory requirements. As per that time, the sample must be retained. So even during that time also, the integrity of sample must be maintained. For that, whatever storage conditions must be provided. So, and that should be monitored. And sometimes we have to return the item to customer, especially calibration item and all. It has to be returned to the customer. So how that is being returned, and if it is not returned, then we have to dispose the sample after a retention time. So how we are going to dispose it? So in all these procedures, so ultimately we have three things we have to consider. One is that integrity of the item. Another thing is that the importance of the uh, interest of the laboratory as well as the customer. So everything must be taken care. As per that, you have to make a procedure and you have to implement. This is 7.4.1. And 7.4.2, the laboratory shall have a system for the unambiguous identification of test or calibration item. So whatever test item or a calibration item received in the laboratory, that should be uniquely identified. So we have to mask the identity of the customer on the sample, because we have to maintain the impartiality. There should not be any conflict of interest must be there, that should be resolved. So for that purpose, the identity of the sample should not be revealed to the testing personnel. So the samples customer identification will be masked, and instead of that, so the laboratory will have unique identification as per the laboratory system, and the samples must be identified as per the system, and all the records, wherever records, whether it's log books, instruments, observations, everywhere, the item must be identified as per the sample code, whatever given by the laboratory. For this, laboratory must have a system. So how to coding the sample. So the laboratory must have the system, And some certain cases, item what is given to the laboratory or sufficient to the laboratory, maybe the single piece, or it may have multiple number of pieces or packs representing single sample. In that case, multiple packs are representing single sample means each and every pack must be identified by the Unix system, that whatever code that is given by that. So that is to be taken care. So 7.4.2 identification of the item system laboratory must have. And 7.4.3, so upon receipt of the test or calibration item, the receiving personnel must verify the samples whether it is received as per the agreed terms and conditions, as per the contract, whether the sample is received with respect to quantity, with respect to conditions, with respect to packs. So everything it should be verified. Any other additional information is required. So as per the contract, they have, it is being forwarded, it contains those informations or not. So everything must be reviewed by the sample receiving personnel, and the sample receiving personnel must be aware of the handling of this test item, and must have the must be trained on the procedure for this class as per class number 7.4, and also as per class number 7.1. So the personnel must be trained, and the personnel must have the copy of these two procedures for handling of the request as well as the handling of the test item or calibration item. And so they have to review whether the item is received as per the conditions, then it is okay. Suppose any deviations are identified, it is not met as per the contract, then the same must be recorded and must be intimated to the customer. So we have received the sample with some deviations. These are the deviations. Then the customer will tell you, so whether they may forward some other samples, or they may instruct you to know the way. So you have to handle the sample to do the testing of the samples, whatever given to you with the deviation. So by acknowledging that, so you can register the samples and forward the item for the testing, but the deviation must be recorded, and even that deviation must be included in the test report also. So what there is as item is received with the deviation, so this deviation may affect the results, maybe because of the deviation that may affect any test result. If it is, if you find as per your understanding, if you feel that that deviation may affect any particular test results, then that also you have to include in the disclaimer. Appropriate disclaimer must be included in the test report. So this is when there is a deviations observed. And as per 7.4.4, the items, so after the during testing and even after testing, we have to handle and we have to store the item as per our contract terms and conditions. When we are retaining the item or handling the item in our laboratory, so the integrity of the item must be retained. So accordingly, we have to maintain the storage conditions. We have to provide the storage conditions to maintain and keep the sample as per the conditions. And the storage conditions also to be monitored and they should be recorded. So this is what requirements of the class number 7.4.4. So with this, I am summarizing class number 7.4. So 7.4.1, laboratory must have a procedure for handling the test item. And as per class number 7.4.2, the laboratory must have a system to identify the sample so that the conflict of interest does not exist. And any deviations are observed when we are receiving the sample, the same must be intimated, recorded, and as per customer directions, so we have to continue or proceed further on the handling this test item. And during the testing, after the testing, the sample must be stored as per the conditions, and the conditions must be provided, and the same condition must be monitored and recorded. So these are the different requirements as per the class number 7.4. So far, any doubt on this?
So we have to maintain documents for this.
Yes. For here, for example, you must have a sample receipt. So that means sample submission form or test request form you must have. and you have to review the item and the review records to be maintained. For that, you must have some system to record the review of the sample receipt as well as test request. And after that, you have to register the samples. For that sample receiving a logbook or register, you must have. Then you have to forward the samples to the respective testing section. For that, you must have chain of custody, maybe job cards, whatever you can call it. You must maintain a chain of custody to record the life of the sample. And after the testing, the sample must be stored as per our retention policy. For that, you must have environmental conditions to be maintained, and and it should be monitored and recorded. So environmental or storage conditions of the sample that should be retained, that will be verified. Suppose if you are returning this.
How long sample to be retained, sir?
What sir? What sir? How long? But that
Yeah.
nowhere there is the hard and strict rule. It is as per your contract or as per your regulations. Suppose in the regulatory samples are they will instruct you to keep the samples for 6 months, or sometime customer may ask you to retain for 1 month or 3 months. It is as per customer requirements or regulatory requirements.
Okay.
If there is no such things are there, then laboratory can decide. They can make, but they have to make some policy. Even they can destroy immediately also.
Okay.
But everything depends on customer requirement. But you must have a policy on sample retention.
Okay.
Okay, sir.
Okay, sir. Thank you.
Okay. Thank you, sir. So handling of test item is okay now? Any other doubt on this? Okay. So next is 7.5, and that is the technical records. So the laboratory received the sample and they are performing the testing on the samples or calibration of the sample or item. And when they are performing their laboratory activities, so data will be generated for each and everything. So you have to maintain the records of handling of the test item and testing of test item. Sir, am I audible, sir? Hello?
Yes, sir.
Yes.
Okay.
Yes, sir.
Some more. Okay.
Yes, sir.
Thank you, sir. Thank you. So we have to maintain the records of handling of test item, whatever testing we are carrying out, all the observations. So we may take some volume of sample or weight of samples, volume, sample size, how much we have taken. So during the testing process, any other reagents are added, any titer value is there, any observation is there, any wrong. So all these things must be recorded. You must have some system to record your observations. Then the original observations must be maintained. Sometimes people will maintain only the derived observation, not the original observations. So you have to maintain the original observation, derived observations, and the calculations, final results. Everything must be retained. So the reason is for any reason, if you it may be auditable for it may, during the accreditation or assessment, the people will come visit and verify the documents or records, or your customer may also come and verify the records, or sometimes there may be some legal issues are there, then you may be some legal battle may be there. For that also you need some documents, evidences. Based on that you will be defended. Otherwise you will not in proper position to defend yourself. So because of that, all the observations, basic small things also you have to record. And when you are recording the things now, whenever you are performing the testing, at the time when the results are observations are generated, that should be immediately recorded in the official registers or workbook or logbook or formats. Sometimes people are recording the loose sheets or rough sheets, then they are making in the original book or registers. That is not correct. So that practice should not be allowed. And always use your official registers or formats to record the observation. Sometimes the register is very, very big size, so you cannot bring the register to your working area, or many personnel are using the same registers, and so it cannot be given to any one single person. In that case, the where technical people can be given a small notebooks, so they can carry the small, that notebooks must be official notebook. It is not rough notebook, it is an official notebook to record all the information. Later on it can be reproduced in the original big size registers if it is there. But even the rough book also official notebook, it is not unofficial notebook, so that you have to ensure that whatever observations must be recorded in the official registers or notebooks only. And also they must be recorded at the time they are making. Sometimes people register now and record in some paper, later on they will maybe next day, like that. That is not correct. So immediately they have to register, otherwise the data may be lost. Once the data may be lost means then the result, for example, a personnel is performing the moisture test, so the drying process will take for 4 hours. So they have taken the initial weight of the uh, dish vessel and the sample initial weight, everything they have taken, but forgot to record it. And they have kept in the oven for 4 hours. After that, the drying process, then they're weighing, they have the final result. But at the time, the original initial results are not there, then how they will calculate the result? So that's why each and every data must be recorded immediately when they are performing the testing. And also, they have to record all the informations are required for calculating the uncertainty, or for any reason the sample is being tested, retested, maybe as per your doubt, or as per your supervisor doubt, or as per your customer doubt. So for any reasons, if you are retesting the item, then the retesting must be carried out as per the original conditions. Like that, whatever instruments that is being used for that previous testing, who has performed the testing, they same personnel will repeat the test by utilizing the whatever equipment or vessels that is being used for the previous testing. Then only you can compare whether the results are okay or not okay. Suppose if you are using different equipment or different personnel, maybe the result because of the change in the personnel or equipment. So we are not sure whether the result is because of change in our condition or change of different personnel, or the calculation or the test is wrong, that we may not conclude. So that's why, so you have to record all the informations, whatever sufficient required for the measurement answer, the calculation and all, it should be recorded. So that's what technical requires. So results, report, and sufficient information to facilitate, if possible, identification of factors affecting the measurement result and its associated measurement uncertainty, date, and the identity of personnel responsible for each laboratory activity and for checking the data and results. Original observations, data, and calculations shall be recorded at the time they are made and shall be identifiable with a specific task. So like that, you have to record your original observations and calculation and everything. And as per class number 7.5.2, so the amendment to the test results. So whatever your observations are the final results, it may be revised or amended. So for any reason, it can be amended. Maybe the personnel who is performing the activity, by mistakenly he did recorded some value, and he realized that it is mistaken, then he may change the value. Or your supervisor, by verifying that he may find some fault, then he may change the value or any figure. So like that, for any reasons, the results or observations are amended or revised, then it is acceptable, but it should be done in a proper manner. So whatever the old result, whatever the new result, both must be legibly known. We can understand that the wrong, this information must be known to whoever is verifying the data. They can understand, so this is the mistake and this is the correction. So what purpose they have done, who has done, when it has been done, all the information must be available, and the original old data and the current data both must be retained for the audit purpose. So that is what the policy and the amendment of records. So ensure that amendments to technical records can be tracked to previous versions or to the original observations. This is what technical records. So how to maintain, what are things are to be maintained and retained, and how amendment is to be made. So everything is addressed under as per class number 7.5. Any doubt on this? Hello?
No, sir.
Thank you. So next we can go for the class number 7.6. That is evaluation of measurement uncertainty. I hope people understand uncertainty. So what do you mean by uncertainty? Anyone? Of course, the
Being we're not sure.
Yes, that means we are not sure. That means we have doubt. We are not 100% sure. There will be slight doubt on our results, and big doubt on our results. There will be doubt. Why we are not sure on our results? Because we only performing the results. Why we are not having confidence on our results?
Because there is some error in instruments, also environmental conditions, and when we do the test by different person, there is some variation in results.
Okay. Performing with a different person, even if same person
Same
is repeating.
there is a repeatability error in the test.
Yes. So there will be variation. So we don't say it is an error. So of course, uncertainty is an error, but all errors are not uncertainty. But there will be variation. Even the same personnel is repeating the testing. There you can find the variation in the result. The reason may be the variation in the environmental condition, variation of the instrument stabilization or equilibrium condition, or variation in the personal behavior. So like that, there are so many reasons are there that have impact on the result. But the impact is not constant every time. Maybe initially it will have this much impact. Next time the impact may be different, slightly different. So because of the variation in the impact of the different sources, you will get different results when we are repeating the test. It is not altogether different result, slightly different result. So that variation we call it as the uncertainty, and it is in the measurement. Uncertainty in the measurement that we have to evaluate. So mostly for the any testing or calibration activities. So for the qualitative parameters, it is not applicable. Only for the numerical value, wherever you are giving, that is enumeration or MPN in the case of microbiology. So those area only we have to evaluate the measurement uncertainty for our testing activities, and also for calibration activities. Also, we have to measure the uncertainty. When the we are evaluating the measurement uncertainty for our test results. So we have to consider what are the factors are contributing towards the uncertainty. It may be equipment calibration, or instrument, or small glasswares, or reagents, or the reference materials, or the environmental conditions. Like that, there are so many activities are there. They are responsible for the variation in the uncertainty. So as per our understanding, as per our theoretical knowledge on the testing and practical experience on the testing, so we can identify various contributing factors for the uncertainty. When we are identifying various contributing factors, so whatever significant we cannot omit or neglect, but whatever insignificant, we can omit such components. But significant components we may not miss, we have to include when we are calculating the measurement uncertainty. So when the factors contributing components means mostly if you say people will say is type A and type B. So heard about type A and type B uncertainty components? What do you mean by type A and type B?
No, sir.
Type B from the certificate value like calibration certificates and type A is test repeating testing, repeatability of the
Yes.
testing.
Good, exactly. So type A is a random error and type B is the systematic error. So random error means it is how we are performing the activity. So in that when we are performing the activity, there will be some variation in the results. So that is called a random error. So that means when you are repeating, you are getting different time, different results in a random manner. So that is due to some random error. It's mostly repeatability or standard deviation. So that is a type A. We are responsible for this activity. So that means data being generated by the laboratory people. So it's mostly type A. And certain things are type B, that is a systematic error. That means it is contributed from the whatever equipment that is being used. From that you can get some contributions and some reference materials you are using. From that you will get some information. So these are all systematic error. It's mostly it's a consistent. It will not change every time. And even if it change, the trends we can predict. So whenever things are predictable and constant, such things are called systematic error. And so both you have to consider for your testing activity. So and mostly when you are calculating the uncertainty, you have to define the measurement formula. So how you are going to define the measurement formula? It is as per the procedure. When you are making that formula, you have to make an elaborated formula. Don't go by a simplified formula. So if you are going by simplified formula, you may miss some important contributing components. So you have to make one elaborated formula for the calculation as per the procedure. And from the formula, you can identify various contributing components by using the fishbone diagram. You can identify so many contributing components. And by identifying the different components, you can classify them type A or type B as per your understanding and based on whether it is random or the systematic. After that you classified, you have to determine each and every contributing components, how much uncertainty is contributing, that will be estimated. In the case of repeatability type A, it is mostly the major contribution is a standard deviation of your repeatability. So, and it is a standard deviation divided by square root of number of trials, that is the type A uncertainty component. In the type B components, it's mostly from the, like madam told, it is from the certificate, like a calibration certificate or CRM certificate. From that only you are going to have uncertainty that is reported in the certificate. And what is reported uncertainty? It's not the actual uncertainty, it is an expanded uncertainty. But when you are calculating, you have to consider only the actual uncertainty. For that, whatever reported uncertainty must be divided by the K factor. Mostly it's a 2 at a 95% confidence level. If it is not given, then we may go, or we have to assume whether it will follow distribution, triangular distribution or rectangular distribution. Accordingly, the device will be different from 2. It may be root 3 or root 6. Or number of trials are there, then accordingly you can use students to T table also for this finding out the factors. So like that, you can calculate the different standard uncertainty from different sources. Once you identify different standard and calculated standard uncertainty for all the contributing components, then you have to convert this standard uncertainty into relative standard uncertainty, because standard uncertainty of different sources will have different units. So when the sources are having different units, you cannot combine. Either you have to convert everything into the same unit or convert into unitless quantity, that is called a relative standard uncertainty. That is, uncertainty value must be divided by the actual value, then both are having the same unit. So numerator, denominator will have same unit, that is getting cancelled, and what you are getting is the relative standard uncertainty for each and every contributing components you can calculate, and you can combine this relative standard uncertainty. When you are combining the relative standard uncertainty, first you have to, it is not simply AB is not A plus B. In the case of uncertainty, you have to square each and every contributing relative standard uncertainty. Then you have to take the sum of this contribution. Then you have to take the square root. Finally, you have to multiply with the average value to assign the unit. So this way you have to do the calculate the combined uncertainty. Then you have to report it. Normally we are not reporting the combined uncertainty. We are reporting only the expanded uncertainty, mostly by multiplying the combined uncertainty by the K factor 2 at 95% confidence level. So this way, so we have to perform the measurement uncertainty calculation. So it depends on the different test method. The methodology may be different. It is not that much easy. In the case of chemical testing, gravimetric, the methodology will be different, volumetric will be different, the instrument technique will be different. Like that, different technique, the template what you have to plan will be different. So accordingly, you have to perform the measurement uncertainty. So as per class number 7.6.2, for calibration activities, calibration laboratories, they have to calculate measurement uncertainty for their calibration activity, and they have to include this calibration, that is uncertainty data, also in the calibration certificate. That is mandatory. Suppose if you are doing the calibration for your purpose and it is a calibration, then you have to, or even for internal calibration activities also, you have to calculate uncertainty. Mostly people are doing by spectrophotometer, other chromatographic technique. So they are telling the instrument calibration. Actually, they are not calibrating the instrument. Only they are verifying the instrument. Simply, people may call it as an internal calibration of a GC or internal calibration of LC. Don't say it's an internal calibration. What you are doing is not calibration. That is performance verification. Simply tell it's a performance verification or simply intermediate check. If that is intermediate check and performance check, then you need not to calculate uncertainty for that activity. If you are claiming it is a calibration, then you have to calculate uncertainty for your internal purpose. I hope people can understand. Yes, many times this will be ANC during audit. Understood this one? 7.6.2. What is calibration? What is not calibration? Okay, but if you say it is a calibration, whether it is internal purpose or external purpose, then you have to calculate uncertainty. Is it okay? Any doubt? Hello? Please mute, sir. Okay. Like similarly for calibration activities, testing laboratories also must calculate uncertainty for the quantitative parameters, not for the qualitative parameters. So measuring equipment, how to calculate uncertainty for that means you are talking about calibration. Yes, I am basically from testing personnel.
Yes, sir. Yes, sir. This is for the calibration only.
Okay. So maybe I will ask sir, because I am not that much qualified to talk about calibration activities, because basically I am a testing person. Okay, sir.
Okay, sir. Thanks.
For the testing laboratory also must calculate uncertainty for the quantitative parameters. So for whoever is doing this activity, they must know the theoretical part of the test procedure, and also they must have the practical knowledge on the testing. So without this, the people cannot perform measurement uncertainty calculation. Okay. Is it okay? Shall
Yes,
I
sir.
move to the next? Okay, thank you. Next thing is that 7.7, ensuring the validity of test results. So here we are doing the testing activity. We are recording all the original data and everything, and whatever activities for that we are calculating uncertainty also. But how much our results are good, are okay, are reliable, are accurate? Who will ensure? Mostly the samples what received in the laboratory is unknown. Whatever results you got, you don't know whether it is correct or not correct because the value is not known to you. It's unknown sample. So you don't know the actual result for the given sample. And whatever your result, that only people has to accept. So we cannot say if anybody asks whether it is right or wrong, then we may not be in a position to tell whether it is correct or wrong. Simply you can repeat the test and you can get the same results. Even if you are getting the same result, your result may not be correct. Yes, it's only precision, but we cannot have any say on the accuracy of the results. That is very critical. So the precision and accuracy both are important for any results, but the samples given to us unknown, so that is value is not known to us, then we cannot measure the accuracy of a result. Of course, we can measure our precision of results by repeating, but accuracy we may not measure. So that the standard describes various control. By this, you understand your results are okay or not okay. So that is addressed under class number 7.7, ensuring the validity of test results or calibration results. So 7 point in this, there are two subclasses are there. One is 7.7.1 that talks about intra-laboratory activities or within laboratory activities. And 7.7.2 talks about inter-laboratory activities or between laboratory activities. So there are two types. The first one is the 7.7.1, that is the intra-laboratory activity. So whatever addressed under this, there are so many activities are addressed. All are intra-laboratory or within the laboratory we have to perform. We need not compare with the other laboratory. So we have to compare the results are in our laboratories only. So the laboratory must have a procedure for monitoring of this validity of results. So whatever results that we got now, so we have to monitor whether the results are okay, precise or accurate. For that, we must have a procedure. And also we must have a plan for performing this activity. And as per our plan, we have to execute these quality control activities. And whatever results we obtained when we are executing the quality activities must be recorded, evaluated, and so that we can understand that we are on the right path or not. Anywhere any deviation is there, then we have to take the required corrections and corrective actions based on the results that we obtained. So the resulting data shall be recorded in such a way that trends are detectable, and where practicable, statistical techniques shall be applied to review the results. So mostly for verifying the precision or verifying the accuracy, we may adopt some statistical formulas and procedures, like even we have to use some control charts or bar charts, something trend chart. Those things also we can adapt for verifying our results and verifying our performance. So this is class number 7.7.1, and in that there are so many activities are addressed. So the monitoring shall be planned and reviewed and shall include where appropriate, but not be limited to. The word is, you please understand, shall include. That means all the things, whatever given under things are included. But at the same time, they have given some exclusions where appropriate. It is not that whatever given under this class are applicable to all type of laboratory, because the standard is a global standard. It is standard applicable to calibration laboratories, testing laboratories, Even in the testing laboratories, there are different type of testing: mechanical, microbiological, electrical, or chemical. Like the different type of testings are there. So that means all the things addressed under this class may not be applicable to each and every laboratory. So you have to think whichever class is applicable to you, then you have to implement. Whichever class is not applicable, you can straight away mention in your quality manual, this class is not applicable, but you have to justify why it is not applicable. Apart from this, some other techniques are there for verifying this validity of results. If you feel, those also you can include apart from whatever addressed under this. That's what standard says. So I will give you one by one, explain you how to implement in your laboratory. So one is the methodology, and the next is the evaluation, how you can evaluate, and what is the criteria, and what is the frequency. So everything I will address for each and everything. In the laboratory means normally you have to divide into two parts. One part is the quality control, other is the quality assurance. The technical team, whoever is performing the testing activity, directly involved in the testing activity, that is called the quality control team. And whoever is not involving in the testing activity, simply they are monitoring this activity, that is mostly by quality manager or quality assurance team. So whatever addressed under this class, certain factors will be quality control team or technical team is responsible. Certain things quality team is responsible. Certain things both are responsible. So accordingly, you can make your plan for executing these activities. The first one is use of reference materials or quality control materials. So reference materials are reference standards. These are all certified things you can procure from outside. Certain things you can do calibration. Certain things you can procure from the 17034 reference materials, or you can create your internally some quality control materials in comparison with the reference materials, because reference materials are so costly. You cannot use in day-to-day activities. So in that case, you can make your quality control material in comparison with the reference material. So that can be implemented in day-to-day time. So mostly this usage of reference material and quality control material, the responsibility is with the technical team. It is not the responsibility of the quality team. It is the responsibility of the technical team. Mostly for every batch of testing or calibration, they have to use wherever required reference standards or reference materials or quality control materials. And this is every batch. Normally, for every 20 test or 20 samples, they have to use one quality control activity like reference material, quality control material they have to use. And the evaluation is mostly you can go with the percentage deviation or percentage recovery. So these are the way you can evaluate. If you are adopting percentage recovery, it may be 70 to 120% or 80 to 110, depending on the concentration level. It may be different. So there will be some lot of standards are available. AOC standards are available. There is some EU guidelines are there, so you can refer to arrive the respective recovery factor if you follow by recovery, percentage recovery. If you go by percentage deviation, then it may be the criteria may be based on the Harvard's equation you can derive. In that case, the reason why we are going on, so that depending on the concentration level, the criteria may be different. For example, if it's the purity level, percentage level, the error only 2% is allowed. In the case of a microgram level, even 25-30% of error is also allowed. So for that reason, you can use Harvard's equation. So for each and every concentration level, you will get some different acceptance criteria. Also, this is applicable, Harvard's equation applicable wherever the concentration term is there. If there is no concentration term, or like the pH or electrical conductivity, for that different units are there. In that case, mostly you can go by either 5% variation or 10% variation, or as per your reference materials, anything is having that the uncertainty they have given. So as per that also you can proceed. So this is with respect to use of reference materials and quality control materials. It is for every batch of testing. The responsibility is with the technical team, and the criteria may be the evaluation may be percentage recovery or percentage deviation, and criteria based on uh, AOC guidelines are there and Harvard's equation there. Or you can have your own, or you can refer the reference material that's being used. And next is that that is use of alternative instrumentation that has been calibrated to provide traceable results. So, for example, for the small instruments, if you have multiple instruments, you have there is no, it may not be applicable to you. And suppose if you have two different calibrated instruments are available, then only it is possible. If you have only one instrument, then you can straight away say that this class is not applicable to you. The instrument like oven furnace, if you have two instruments, then this don't apply this for the validity of result study. If you have different balance, or if you have different high-end instrument spectrophotometer, or if you have spectrophotometer and you visible spectrophotometer, atomic spectrophotometer, like that, if you have different instrument techniques are there, then you can apply this technique for ensuring the validity of results. Otherwise, you can simply say it's not applicable. And here the frequency, don't do every day. Maybe you can have once in a month or once in a quarter. If you are, if possible, you can include with alternatives which can be applicable. And the responsibility is with the technical team. And the frequency, my suggestion is once in a quarter. And the evaluation based on percentage deviation, and for that criteria based on Harvard's equation or 5% or 10%, like that you can have the criteria.
Sir, CRM sample is compulsory.
CRM is compulsory for the traceability, that is mandatory for traceability. Wherever traceability is required, because each and every result, you have to establish metrological traceability. For that, CRM is mandatory. For ensuring this validity of test results, that is for comparing whether your results are okay or not okay, you are verifying. For that, you need not use everyday certified reference material, but you can create your own control materials or reference materials in comparison with the certified reference materials that can be used day-to-day basis. So CRM you may not use day-to-day, maybe once in a month or once in a week you will use, but you can use these control samples, control materials that can be evaluated against the reference material that can be used every day.
Okay, sir.
Thank you, sir. Okay, so alternate instruments. So A and B we have covered. So now it's 3:30, and we can have a break now. Please assemble by 3:45 to continue the remaining part. Is it okay?
Okay, sir.
Okay, sir.
Thank you.
Roger.